and welcome everybody to my talk on how we can keep our code refactorable. But before we dive into the content, I wanted to lose a few words on myself so that you know what kind of person you're dealing with. So again, hi, I'm Gerrit. I'm a full-stack developer at Accenture. I got there in 2016. I joined as a dual student, did my bachelor's degree in a partnership with Accenture, and then graduated in 2019 and got a full-time job as a full-stack developer. In my free time, I like to cycle, especially over long distances and with all the equipment on the bike called bikepacking. My last single day trip was 200 kilometers. My last multi-day trip around 900 in a week, hoping to double that in the next years. And then also I'm quite a big Tolkien fan. I read basically all the books, and fun fact, there's not only the Lord of the Rings and the Hobbit, but quite a lot more, especially about the early ages. But not enough about myself. Let's talk about the content. So here's my plan for the talk. We start with what and why. So what is refactorable code? What do I mean by that? And what do I need it for? And then we dive into 3 practices that I want to cover on how we can achieve refactorable code. And then for each of those, there will be a few tips and tricks from recent project assignments, from talking to colleagues, from other conferences where I held the talk already. And then last but not least, there's a Q&A session, as we just said. So we can talk about a few statements that I made, about my opinions, but especially about your opinions, your questions, and maybe some doubts that you have. Maybe there's things that you see differently, and I'm happy to discuss. So yeah, let's go forward. The what and the why. So usually when we think about refactoring, we think about a one-off activity that is performed on a particular part of the application code in order to improve it. This could be fixing a bug, adding a new feature, making it more readable, or simply restructuring it. The problem with that is that these changes might have side effects, and then we break another part of the application and maybe another one and another one. It could be a chain of problems. So there's a certain risk involved. And from that risk, there comes a lot of hesitation and fear, not only for us as developers, as we say, well, I'm not certain if I want to do that change of that part of the application code, because I might break something different and I don't want to be the person to blame. But also from the perspective of our management in the projects, where I think it's very unlikely that you find a manager who's saying, yeah, please go forward with your refactoring and we will somehow make it for the go live in 2 weeks. I think that's very unlikely. We all want to minimize the risk and to minimize the problems. So what we have is we have a lot of hesitation, we have a lot of fear, and therefore we often don't do the refactorings that we so desperately need, because there's a problem in our code, and that's the point where we come from in order to do the refactorings. But in the end, we don't solve it. And I think that's a very, very big problem. It's a huge problem. And I think we need to get away from that. We even need to get to a point where our code is in a state that constantly allows us to do these refactorings that we so desperately need. I think that we need refactorable code. And what I mean by that is that we try to replace the hesitation and the fear and instead move confidence at the center. And if we move confidence at the center and have a look at the 3-step software development approach here, then as a first step, everybody in the team, including the new joiners, should have a fair chance of reading the code with confidence in order to get a rough idea what's going on and maybe what's not going on. So what's the idea, where do we come from, where do we want to go with the code? And then based on that, there can be conclusions and a better understanding. What is actually happening? What is happening under the hood? What does the code do? What does it not do? Why does it do it in the way it does it? And that foundation then is required in order to do the adjustment that we need. Add another feature, fix a bug, make it more readable, restructure it. And the whole thing is a circle. So after the adjustment, we set the code back into the same state, which again is centered around confidence and it allows us to do the next step, the next refactoring. And the confidence, instead of having hesitation and fear, now allows us to move forward and know that we actually do an improvement and we not just have problems left, right, and center after our refactoring. And I think we need to get there. And we need to get there because complexity in software development projects in our world is ever increasing. By now, there's more systems, more APIs, frameworks, and languages. There's a cloud, there's hybrid setups, there's IoT, there's AI, there's big data. There's so many topics growing and expanding and will get more and more. And we somehow need to accommodate all of these. We as developers, we need to cope with all these challenges and build skills in those fields. And while this complexity is rising on the one hand, on the other hand, we need to deliver the software ever quicker. And that is a problem. Software is moving into the center of almost every business model. And if it didn't do so yet, it will do so in the next years. And delivering software fast is essential to gain a competitive advantage over your rivals. And that can be win or lose. You could be out if you're not fast enough. So time to market is getting more and more crucial. So we have a rising complexity and a decreasing time to market, and bringing that together with hesitation, fear, and risk is not going to work out. And I think confidence is the only way forward that also allows us to be fast enough in order to face these challenges. And now let's talk a bit more about what I think we can do in order to get there and how we could achieve refactorable code. And what I brought here are 3 practices that I think are very central in this approach. And we're going to talk about unit testing, clean code, and finally code commits. And now you might be wondering, well, these are not some superhuman weapons. This is not a new framework, not a new technology, not a new service from a cloud provider. This is very basic. We almost expect every developer to be capable of working in these fields and to have the skills required for that. And I think this is exactly the point. We all could remember a project where there was a high pressure environment and where we basically had to deliver feature after feature. And I think we often throw these 3 practices overboard. So when on a Wednesday you work on a feature because you want to deploy it on Friday, but there's still a bunch of stuff to do, you might skip the unit test because you need to get to the next feature quickly. Same goes for clean coding. You don't reflect on the changes that you make, but you simply push them into the repository as soon as they seem to work. And finally, the way we package these changes often suffers quite a lot as well. There's always the guy or the person in the team who's doing the same commit message 15 times, and you need to decipher what really is the change and what changed under the hood. So I think these 3 are very quickly suffering in our project when there's a hard constraint and a hard problem with time. But they're definitely not the only ones. You can see a lot of smaller gears. There could be style guides, conventions, pair programming, mob programming, different kinds of testing. There could be automation, tooling. There's a lot more options here, but I want to focus on these 3. And there's one last step before we actually dive into the first practice. Now, I'm with software development not for many, many years yet. There's people out there, you who are a lot more senior, a lot more experienced. But I wanted to emphasize that I think there is a broad range of people and a community around this idea of having better quality. And this is why I collected some Twitter impressions over the year that I wanted to present. So if, for example, you look at the top left, there's a quote by Jeepa Hill, and it goes like this. If you care about productivity, you care about the internal code quality. If you want to go faster tomorrow, you care about the quality of the code you wrote today. And I think this is a very nice point. It gives us some kind of image in the head of a snowball effect. You want to put in some more time today to have a better quality, and you can leverage that multiple times in the future because it will have kind of a snowball effect. And then in the bottom left, don't comment bad code, rewrite it. This is a lot into the direction of clean code. Reflect on the naming, reflect on how you want to bring meaning to other people, reflect and think from the perspective of others. And then finally on the right, and I think this is my favorite one especially for today, we don't write tests. Why is that? Because we don't have time. And why is that? Too much work and pressure. And again, why is that? We don't move fast enough. We can't cope with the work fast enough. And again, why is that? Well, software has become difficult and risky to maintain. And then the final why, well, because we don't write tests. So there's an evil loop which is always keeping us in a bad state, bad quality, and makes us slow. And we don't go forward fast enough as we might want to. Okay, I think we are ready for the first practice, for the first idea, and we dive into unit testing. But before I continue talking, this is the very first question to you. So what do you think? What are reasons not to write tests? And you can just use the chat. I will log into the second PC again to see what you are typing. And I'm very much looking forward to your ideas. So what are reasons not to write tests? And I'll wait a few seconds here so that everybody has a chance to think about it and send the answer. And I think the stream is also delayed by a few seconds, so it will take a few seconds until I can see. First answer, bad code. Oh, yes. 100%. Totally with you. Not knowing how to, in terms of skills, yeah, maybe. Yeah, if you're the total new joiner to software development in general, maybe that's tough, or the technology is just unfamiliar. Tough technology, yes. Too much boilerplate. The code is not testable. And then there's someone true to the point, no excuses. Very nice. Yeah, I think you're ready for your ideas. You can keep on chatting and exchange with the other people. But I want to take a few of these points and put them also into the talk now. Because there's one point where somebody said bad code, bad structure, maybe the code is simply not testable. And I actually brought an example for that. So I brought a negative example and I called it messy structure. And here's the setting. So imagine you are in a company and you have an application which produces PDF documents. It could be in any scenario, whether it's governmental, in the banking sector, automotive, business to business, it doesn't really matter, but you produce PDF documents. And there has been a small team working full-time on that for almost 2.5 years now. So it's quite feature-rich. But on the other hand, nobody ever wrote a single unit test for this. So after 2.5 years, there's exactly 0 tests. And this will be the setting for the example to come. So keep in mind, it's a PDF service, 2.5 years of development, exactly 0 tests. And now you are a new joiner. You come into this team and yeah, you get assigned your first task. And it's really your task because everybody apparently and unfortunately is on sick leave or on vacation. And you're the only one left. Maybe it's in the Christmas holidays or so. And your manager, she's approaching you and she says, well, we have this critical feature. We need to add a header to every PDF page that we create in whatever document. To every new PDF document that we create, every page has to have a header. And the content, the information that we display within is the name of the board of directors. And you might, well, you maybe already know we are active in 192 countries and we have a gazillion types of company structures and organizational structures. And the combination, it must be perfect in every single case. So different languages, different organization types, different names and different orderings of the board of directors. So quite a lot of edge cases. Well, and then you as a new joiner, you say, well, okay, I'm going to write tests for that. I'm going to write unit tests so that I can simply cover all the edge cases. And then I know, well, if it works today, it will work tomorrow, it will work in a week. But then you see the code on the left. It's highly convoluted. It's hard to read. There's this one God method called write PDF, and it does everything. And there's some loops with cryptographic variable names. There's hard-coded strings, if-else statements, and some of them are simply empty. Some cryptic if statements where you don't really understand the conditions. Error handling is done in a way of printing something to console. So really, it's not the best code. And you're faced with a challenge now. You have a problem. And the problem is this. If you were to go forward and actually write unit tests based on this, it would mean the following. You would have to mock all the input parameters of this method and set all the values correctly so that there's not a single branch of this God method which will fail until you get to the point that you actually want to test, so that you move around all the problems and get to your feature in order to test it. And as a consequence, what that will mean is that you will have huge testing methods. So not only is your application code quite messy and convoluted and bloated, but now your unit tests will become so too. And not only is the application code therefore hard to maintain, but now your tests will do so as well. And on top of that, you will have to invest significant amount of time in order to write all these tests because of all the setup that you need to do. Or maybe there's a lot of teardown as well. So there's quite a big problem now. And the interesting thing about this situation now is that this is the very first time after 2.5 years that somebody is looking at the application code from the outside, from a different perspective, from a different angle. The moment you write your first unit test, basically any test, you become the client of your own application code. Similar like you would use a library in your application, you now use your own application in the unit test. And this gives you a different angle on how the code is written, how the structure looks like. Somebody of you in the chat just said, maybe the code is not testable. This is exactly what you realize now. You don't realize that if you just add new features, because simply adding the feature might not be all too hard. But there's no safety guarantees that actually it works because there's no test. And there's no reflection on the structure, which might be a problem in a few weeks, because then you are really at the dead end with a lot of problems that you need to solve so that you can actually add the next feature. But you're the new joiner, you say, well, I'm going to push through now, but in order to write proper tests, I will have to clean up the structure first. And you do exactly that. You might end up with code that you see on the left. So the method now is significantly smaller. It still covers the entire writing of the PDF, but what you see within is that there's dedicated classes for the different responsibilities. So now you have a header writer, which is only performing tasks on the header. You have a content writer only for the content, same for footer and metadata. So what you did is you moved responsibilities into dedicated classes. And what that will give us, it will give us a super nice testability, because now we can write the tests based on these dedicated classes and methods. And therefore the testing scope and the setup that goes with it is significantly reduced. We can focus exactly on the point that we need to, and we can focus on exactly one task and test only that. Makes it a lot easier to write the tests and also to maintain them. But also, on top of that, you've now flattened the structure of the code level. It's easier to understand, easier to read now, easier to maintain. And maybe if the next new joiner comes, it's even easier to join now. So very, very cool. There's a few things that we did which are a great advantage now and a great achievement. You've introduced a clear separation of concerns, and you did that by thinking about tests and how you then become the client of your code. You had the chance to view your own code from a different perspective and see it with a different angle. You've moved the responsibilities into dedicated classes and now have scopes, and the classes don't do everything, but only their particular task. And therefore, you don't only have proper testability for the feature that you're working on, so the header, but all the other features are significantly easier to test now because you've well structured it, and the test scope is therefore reduced. It makes it a lot easier to write and maintain. And then as a snapshot, in this very moment, you've also significantly reduced the technical debt. The application code is a lot cleaner now, and it's easier to understand, and therefore the risk of it breaking together and making it impossible to add new features is significantly reduced. But what are the lessons that we could learn from here? I think it makes sense to write tests from the very beginning. So to start with tests right from the get-go and not only add them after a year, because that immediately gives you this different angle to view your own code from a different perspective, to reflect on the structure, to rethink if this is really a nice approach. The moment your tests become hard to write, this is a tell, it's a code smell that there might be something wrong with your application code. And then furthermore, for every individual test case, I would say you could follow something like a test-driven development approach, where you go ahead and you write down all the test cases before the implementation and you let them all fail first. And the reason for that is basically two things. The first one being, only if they all go red, you know that there's not some kind of dark magic going on in your code that magically makes all the tests pass, so that you can be sure that the implementation you're about to do is the one fixing the test. And then on the other hand, once you have 100% green tests, you know that you're basically done with the feature, because every aspect of the feature should be covered with the test, or at least most of them. And therefore you have the feedback that you've covered the greater aspect of the feature. And then finally, it's always good to keep tests simple. We heard that in a previous talk by Sebastian, who talked about Quarkus and stuff. And he also said, if you keep them simple, they are fast. And if they are fast, people are going to execute them. If it takes ages to bootstrap and then run the tests, nobody is going to leverage the power of testing and the feedback that you get. And the feedback can be so powerful because it's automated. You write the test once and everybody can execute them. There's no manual debugging involved. Nobody has to tell you in order so that you know how to test the application. It's all written down. So I think from here, we learned quite a lot of how unit tests not only can give you a safety guarantee through being tests that tell you whether it's good or bad, but also help you to get a different view on your own code so that you have a better and a cleaner structure. And as a next step, I want to dive within the structure and look a bit about the content that we have inside. And the topic here will then be clean code, so the way we write the content in the structures. And similar like before, I would like to start with a question to you again. So what do you think, what is clean code for you? What do you define as clean code? What are important aspects of clean code for you? Again, you can just use chat. It takes another few seconds until I can see the first of those, I think, because the stream is delayed. And I'll happily wait for that. Let's wait another few seconds. Understandable and maintainable code, easy to read, short messages, clear names, structured, small methods, one purpose. Clean code is impossible in some projects. Well, maybe. Written by me. Okay. Different kinds of design patterns. Cool. Again, you can just go on with the chat. I'll happily follow up on that later in the talk. But there were a few very nice points that I want to cover as well. So cleaner structure, readability, short methods, clear intent. And the different sources I got my impression and my approach to clean code now by now are different. So first of all, obviously experience from projects. So hands-on coding, discussions with colleagues, but also the book that you see on the left. So there's this book by Robert C. Martin. He's often called Uncle Bob in the community, and he wrote the book Clean Code. And there's a few points within the book, but also from personal experience that I want to highlight here. And the very first one is similar and familiar already to what we've learned before. So not only from a unit test perspective, there can be an approach to separation of concerns, but also from a clean code perspective. So Robert C. Martin says we need to split up our code. We need to have proper scoping. Because if the scope is too big, nobody has the chance to mentally wrap it all together and understand it as one big piece. Smaller scopes are a lot easier to grasp, a lot easier to understand, and therefore a lot easier to evolve. And when you move things into different scopes and concerns, you get the chance that you name them. So for example, if you think about Java classes, if you split a class up into two classes, you have to give them a name. And that name can transport a lot of meaning, and it can transport a lot of intent and information, so that people who didn't write the code have a far better chance to understand what you mean. And if we put this to a next level, maybe to an extreme level, maybe this is utopia, we can end up with code that is readable like a book, so that there's actual English sentences, English in most cases at least, so that I can read the code from top to bottom, left to right, and already get a clear idea of what's going on without having all the domain knowledge, without having all kinds of technical terms in the names, but just to get a rough idea. And what that will help us is It will give us a chance to have a faster onboarding, for example. New joiners can, on their own, far better read the code and have an easier understanding of it. And then the last point, and this is the most important to me, I've often noticed, also with myself, and I hate it, I've noticed a mindset of it works. And I think that is simply not enough. And to describe what I mean by that mindset of it works, I brought this image. So there's a colleague of mine, his name is Holger Zahnleiter. He self-made this image and he presented it himself in an internal conference about software quality in this year's summer. And what we see here is a house where the entry level is in the first floor. And then the stairs go up to the entry door, but they block the window. And the doorbell is at the bottom. So you smash a doorbell, you sprint up the stairs, and if you're not quick enough, you don't get inside. The rain pipes on both sides are falling off, and they're just being held by some kinds of sticks here. There's some nails in the wall and a pipe going into the ground. The chimney is a bit off, and that window also looks a bit weird. So in total, you have a house that probably works. I would guess that you can live in there. You can sleep in there, you can eat in there, probably more so in summer than in winter, but it works for the moment, at least for the moment. But then over the months and the years, problems are going to come. Maybe the rain pipes fall off. Maybe you get problems with your knees and you can't get up the first level anymore. Maybe the chimney falls off and you can't really use the heater anymore. So there's already a big amount of risk built into the product the moment it was delivered. And I think this is exactly what It Works captures. So instead of reflecting on the changes of the new feature of whatever we did, instead of reflecting on that and thinking from a perspective of others in order to improve it, to make it better, we simply go ahead and release that change. We push it into the repository and we don't really think about it anymore because, well, it works. Why should I care about the rest? Maybe we simply forget to care about the rest. And I think this is really, really dangerous. And this is where quite a lot of the risk that we saw in the very beginning is coming from. And again, what are lessons that I learned? And basically 2 of those 3 I learned the hard way. I think it makes a lot of sense to invest a lot of time into finding speaking names. And you need to invest even more time in the beginning because you need to practice. You need to practice to find names for that particular use case, for that particular scope. And you need to find concise names because you don't have free text, but you only maybe have a class name or a method name. That takes a bit of practice. And I already have the feeling that I got better over the months and years. And by doing that, again, we should apply a view from other persons in the team. We should try to think whether other persons can actually understand. One good way to enforce this, for example, is code reviews with pull requests, there where another person has a look at your code. But even if you don't have that, and I hope you do, you can do a lot of reflection on the code yourself. Rename the variable once, twice, maybe even 3 times to find a better name. And it's totally fine if that takes a bit of time. But you will get better in the end. And then as a second point, I think that it makes a lot of sense to have as a rule of thumb at most 1 public method per class. And the idea behind this is basically 2-sided again. First side is, if you imagine your favorite IDE and you start typing the class name, and then you get a gazillion amounts of suggestions of methods to call on that class, you're most likely confused. Which is the correct one? Is there a deprecated one? Is there an ordering in the methods? And it's not really clear on how to approach the class. If on the other hand, you only have a single public method or very, very few, this is a lot easier. You have a clear entry point. You have a clear exit point of the class that the other part of your application is communicating with. So that makes understanding a lot easier. But also from the idea of scoping, if you have only a single public method, you're already starting to reflect if that public method really does only one thing. And this is another rule of thumb that I took from Uncle Bob. So a class and therefore the public method inside that should have exactly 1 task and not really any more. If you try to describe the scope and the responsibility of a class and you use the word and, so A and B, you could think about splitting it up into A and B, so 2 classes at the end. And then finally, and I really learned this the hard way, exceptions, again, if you think in Java terms specifically, they are not the problem. They are part of the solution. If there's an exception in your code, that means that there's a problem inside your code, not the exception being the problem. And we should leverage that, and we should leverage error handling and exceptions really from the get-go so that they are built into our application. Because exceptions are part of the language feature. They are built into the language and from there into frameworks, for example. If you look at Spring Boot, there's a global error handler that you can implement so that any exception which you didn't catch until now is then handled, maybe in order to answer an HTTP client with an error response or so. And we should really start to leverage that. Returning null in a method in case of a problem, a business problem, is not error handling, that's error shifting. You just move it to someone else's responsibility. And I want to bring all these points together at an overview. So I brought a code comparison. On the left side, you see the negative version. On the right side, you hopefully see the positive version, at least from my point of view. But we start with the left. So you have a method, it's called print. What could it print? I don't know, you go forward. You have 3 input parameters. They are S, Z, Z, and H. Again, you can't really tell what that means. Some kind of abbreviation probably. Then you have an if statement. Again, you are the new joiner. You don't really know why is it equal 5? Why does it have to be greater than 0? What does all that mean? So again, difficult to understand. But if that if statement, however, succeeds and returns true, then you do some kind of formatting and you print whatever you have formatted. And basically, you don't really have any idea of what's going on here. But if the if statement, however, goes not so well and you end up in the else case, you have proper error handling here. Wrong is printed to console, so you know exactly what the problem is. It could be any of the 3 input parameters, it could be all of them, and there could be other problems as well. You don't really know. And the problem is not handled. Yeah? You might face other problems now down the road because you didn't really care about the problem that you face here. And I think it only takes a few minutes to get from the left to the right. And then if we look at the right example, the method is now called print address. And even I, as a new joiner in the team, I can almost stop reading here and already have a rough idea of what's going on. I'm going to print an address, and that method is not returning anything. I can see that from the void return type. So it's probably printing an address to console. But you might be wondering, how is that happening? Is there any exception to that? So you continue reading. And you see now it's got street name, house number, zip code. So you see the different parts of an address. Makes it a lot easier to understand what these stand for. And again, you go forward, you see the if statement and immediately notice, well, it's moved into a dedicated method. So now we jump to the bottom. The actual conditions are exactly the same as we see on the left, but now I've wrapped it in a method. And that method is called isValidAddress. Because what that will give me is, it will give me the chance that I can put a meaning around a cryptic looking if statement. And from there, almost have an English sentence, because now I can go ahead and say, if this is a valid address consisting of street name, house number, zip code, well, then please go ahead and format these parts into an address and print that address to console. And if, on the other hand, it is not a valid address, I can now throw an invalid address exception. So I have something in mind for this business exception. I have a dedicated custom Java exception written for that. It also takes the 3 input parameters that I have from the method. So later down the road, I can log it. I can send an HTTP response. I can clearly figure out which of the 3 is actually the problem. And I can dive a bit deeper now. So again, I think it only takes a few methods to get from left to right, but investing the time makes it so much easier to read and almost snowballs as soon as the second person sees the code, because that person will need less time than you will need to refactor it. So now we talked quite a lot about the content and how we can hopefully bring across meaning a bit better in the code that we write. But I think there's another practice another tool and technology that we can use in order to bring even more meaning across and more documentation, more intent, so that everybody else in the team has a better chance of actually following our thinking. And that very practice is code commits. And you might have guessed it, I have another question for you. So for how long do you usually work on a single commit? So how long does it take until you commit after changing some stuff? And again, please use the chat. I'll happily wait a few seconds. I will wait a few more seconds. And yeah, you already caught me. There could be a null pointer in the example before. Totally true. Didn't handle that. And to be honest, I didn't think about it. You got me. Okay, until the feature is finished, 1 minute to 4 hours, once a day, 2 hours, 30 minutes. After the local test is successful, so not really a time frame here. 1 round of TDD a day. Okay, cool. Thank you very much. I think we got a range of answers here, ranging from a few hours to once a day to having a feature complete. And I tend to move to the direction of the people who say a few hours, because I say that, or I think that a proper code commit is well scoped. And that basically has two sides again. It could be too big and it could be too small. Let's talk about too big first. And again, there's 2 points here. First of all, if we touch too many classes, too many responsibilities, the scope of our changes increases. And that makes it harder for us to understand, but also harder for others to understand. And therefore, bringing across the meaning, the intent, and the goal of the change is significantly harder for others to see. But also, if I have more changes and I sum up all the changes over hours and maybe days, then if I at one point, and again, think about being a new joiner, I see that the approach doesn't work, the approach that I chose doesn't work, I need to go back. I could hammer Control Z and hopefully find the place where I'm good again and feeling confident and move forward. But I'd much rather have a safe game, so a different commit that is only a few hours old, so that I can jump back and from there start from scratch. So basically like having safe games. And then on the other hand, a commit could be too small. And then obviously, technically, we need to change at least one character, otherwise Git won't recognize it as a change. But to be honest here, if I would say that you need to pass at least the local quality checks, whatever that might be. For example, in terms of Java, again, you need to compile the code, you need to unit test it. And then finally, maybe something like SonarLint, so static code analysis, maybe some kind of reporting. So different kinds of quality checks locally. Because only if it passes all these changes, it has a chance to pass these on the pipeline on the server. And only if that happens, I can have a deployable commit. If I have a bunch of commits which don't pass local pipeline and therefore don't pass the CI/CD pipeline on the server, then jumping back from the current commit that is deployed on the server to a commit that works is quite a big leap and therefore quite a big change. And that should really be not the case. We should have quite a lot of small changes. And on top of that, I would say that you don't have to be feature complete with a commit. This is what I would use branches for. The branch at some point when you merge it should be feature complete, but your changes can be small baby steps. And those baby steps are supported through tests, like somebody said in the chat, through a round of test-driven development, for example. So rather keep them small than too big. And then once you've decided on the size and the scope of the commit, it comes to the point where you need to document it, where you need to find a commit message to that. And I would say, let's focus on the why in the commit message and describe and document a proper approach and why we've chosen that. The what is somewhat documented by Git automatically. It will track what changes were made in which classes. And everybody can see that, for example, in GitHub when we do a merge request. What is not so clear to understand and to see, especially, again, I'm putting a lot of points on that for new joiners, is the why. So explaining why a certain approach was chosen, why a library is favored over the other, why a different interface was introduced and not handled another way around. This is basically where we bring the most meaning across, and this is what we should focus on. And I think Igor Mina agrees with me, because I think it was 2 weeks ago, he tweeted about a masterpiece of a pull request, as he named it. And that is a pull request by a person called DevVersion on GitHub. And it was a pull request on the Angular framework. And what that person did is he or she did a total of 74 commits, over 800 classes and files changed, and a total of 4,000 lines were removed. So there's quite a significant amount of work going into this pull request. And as you can see on the left, each and every of those commits has a template to it. So there could be a different type of a change. It could be a refactor, it could be a feature, it could be a build. And then there's a short summary of actually what happens, and a summary should actually focus on the what. But then as soon as you dive deeper and you look at the whole commit message, as you see on the right, it is very well documented. The approach is documented. Why was a certain approach chosen? Why can we not call a different API on that library? Why does that not work? Where did you see problems? Where do you maybe have to extend the solution in the future? And what Igor Mina said in this case is, although it was a huge pull request, he had an easy time reviewing it because it was easy to understand and easy to follow for him. So not only was it quick, but it was nice to understand, and it was merged to the master branch rather quickly. In fact, it was even merged too early. That's a little side fact, yeah. So I think we can leverage that to bring a lot of meaning across. And again, if we bring these commits and scoping and commit messages, if we bring that together, I think the most important point for me is that I have to think from the perspective of others. Documentation is not only for myself, there's a team I'm working with, so why not think from the perspective of others? Not only in terms of the size of the changes and the scope, therefore, is it easy to follow? Is it too big? Is it maybe even too small? I think that could be argued as well. But also, did I find a proper commit message to that? Do I actually get the point across? And then as a second point, have fallbacks and rollbacks in mind. What I mean by fallbacks is that you have safe games for yourself, so that every few hours, maybe you have a commit, you're doing these baby steps that are maybe proven through test-driven development, and you can fall back to those. And in case you're following a new approach, you want to try out something because you're not sure if that works, and it doesn't work, you just throw it away, no problem whatsoever. Rollbacks, then, I mean, is what we have in the pipeline. So try to pass and always pass the local pipeline before you push something, because otherwise the CI/CD pipeline will definitely fail. You could enforce that through Git hooks, for example, client side, so that every commit and every commit message is properly scanned and verified, maybe. And then last but not least, leverage the history, especially with nowadays tooling. The branches in our IDEs are colored, and I can see all the steps that are taken, the entire history. For every line in the code editor, I can hover over and see who changed it when and from what to what. And if I have a proper commit message on top of that, I can also understand the why, and I don't need code comments that much anymore. And now if we bring all that together, I think there's a huge number of advantages that we could gain from refactorable code. First of all, if we think from a perspective of others, if we focus on the team, I think that we can make the code a lot more easy to read. And therefore, we can give people an easier time getting a rough idea of what the code does, and therefore have a better onboarding. And if we bring that to an extreme, we have a readability that might almost be like reading a book, where it's not as hard to go from method to method and from call to call, where you have to stick to a method and invest 5 or 10 minutes to even get a rough idea, but instead you have a flow on reading. And then what that will also give us will give us a better understanding of where problems in our code lay. Things that are not as easy to read, maybe things that are not as easy to understand. So we have easier points to identify in terms of technical debt, and therefore we can reduce them more easily. And then when it comes to conclusion, I have automated tests through unit tests now. So everybody in the team can execute them. Not only the author, not only people who know the application and click through it and do manual debugging, but basically everybody can. And from there, we have technical documentation. Every unit test has clear input, clear output, and therefore defines what is expected of the application. This can also significantly help developers get up to speed quickly because they can better understand what a certain method is expected to do. And then as a next step, as I already mentioned, once we decided on the scope and we try to commit our changes, we can leverage the change history as another part of the documentation, as a focus on the why. And we don't need code comments anymore, because code comments, I would argue, are harder to maintain than commit messages, because comments stay in the code and they can rot. Commit messages are point-in-time documentation. They will change with every change that you make. So they evolve with the code, not against the code. And then again, if you have a basis, you have made your understandings and your conclusions, you can jump into the phase of adjusting. You can try out your feature integration. And with every line, every change that you make, you can execute the unit tests because you kept them simple. They are fast and they give you immediate feedback on if you broke something or not. And if you broke something and maybe an approach doesn't work, you have rollbacks at your hand so that you can just jump back a few hours without losing too much time invested. You have the pipeline in mind so that you can actually deploy the changes on the server. And finally, we saw that in the example with unit testing it rather at the beginning. If we try to structure our code in a readable and well-structured way with a separation of concerns in mind, for every feature, there will be a certain testability. Writing the tests will become significantly easier if we just write the tests right away with the feature. And if tests become hard to write, then this is a clear tell that the code is getting worse. So it will give us another layer of feedback here. So what we see the same diagram we saw in the beginning, where I thought about and talked about that we hopefully can replace hesitation and fear and risk with confidence at the center, so that even the new joiners can go ahead in the code and find the right place, understand what's happening, understand what is not happening, what edge cases might be, and from there do the adjustment that is so needed. Instead of being in fear that they don't have the knowledge, that they don't have the skills, and that they cannot go forward with the change. And I think only that confidence will give us the speed and the agility that we need to overcome, that we need to gain in order to overcome the complexity that I mentioned in the beginning. And now, as a final conclusion, before we jump into the questions finally, I'm very well aware that this is not an almighty solution. Again, these are very basic skills, and we almost expect every developer to be capable of applying them. But I think talking about this approach and quality and speed and how we can get there is another basis for discussion. And it's also a basis for a shift of mindset. Again, not only for us developers, but also maybe for the management. We as developers, I think we need to fight more again for situations and projects where we are not under constant time pressure, where we have to throw our quality checks overboard. We have to throw our tool set overboard, but instead a place where high quality is favored and is actually appreciated in order to move forward quickly. And we can enforce that and we can argue about that if we approach our management and we say, well, in order to make the deployment this week, we can totally skip the unit test for the new features. But that might mean that next week, the week after, and all the weeks following, we might not make the other deployments, because then in terms of quality, we are behind. And there is a risk to that, and we are not sure if we can actually follow up on that risk. And then as a final point, I think in order to get there, to value and favor quality again, we need a lot of mentorship. We need to learn from each other, the old from the young from the old. In order to appreciate the quality, to have the common goal, to move forward as a team, to think from the perspective of others, and to live up to a culture where we work as a team on high quality software products. Because I think this is the only way how we can keep our code refactorable. Thank you very much for your attention. Happy to answer questions now. Thank you very much.
Okay, So for the people in remote, feel free to still write your questions into the chat. And for everyone here, just raise your hand and I'll hand the mic over to you if there are questions. Okay. I don't see any hands, just for Gerrit, because I think he doesn't see us here.
No, I don't. Thank you.
And I'll have a look into the chat. Oh, there is a question. I'll read it. Oh, can you read the chat, or should I?
Yeah, I can. Yeah.
Should I read it out?
Yeah, please go ahead, then everybody knows.
Okay. So a question about testing. I guess everyone knows these tests where every numeric variable is assigned to one to first. The tests still pass even if you change the code in crucial ways because everything is one. Any idea how to prevent this beside explaining it again and again? Did you?
I got the point, yeah.
Okay.
So I think the question goes into the direction of having super simple tests that don't have real values, but only placeholders like 1, like 99, like empty string, whatever. I think the biggest point goes into the direction of mentorship and saying it again and again. You can almost enforce it if you go ahead, for example, in code reviews, you have a merge request of a certain feature, and you not only pay attention to the application code, but you also pay attention to the test code. And if you say this is a quality standard that we don't want to value here, then you can say, well, I'm not going to approve this pull request. And then obviously from there, you have to do a lot of explaining and make clear why that is a problem and what problems you might face. I think that's one way to somehow enforce it. And then you as a team need to find a solution. But I think it's important to bringing the point of quality, how that might make us slower today, but it will certainly snowball in the future. I think it's very important to highlight that over and over again. Hope that answers the question.
Okay, so as there are no questions in the chat, I think, is there still a question in here? Okay, no hands. So thank you, Gerrit, for your interesting talk, and thank you all for listening. And I think Gerrit deserves a round of applause. I hope he can hear it.
Thank you. Yeah, I can hear.